Now it's Theorem 8.5. In a quadrilateral, if a pair of opposite angles are equal, then it's a quadrilateral. So basically you need to make a parallelogram only. Name as A, B, C, D, and by the theorem opposite angles are equal. Let in the quadrilateral ABCD angle A equals to C, B equals to D to prove ABCD is a parallelogram. Proof. Since angle A is equal to C, angle B is equal to D, we will add up A and C, as they two are on the left hand side and these two also on the right hand side. We will add up both. For angle A plus B is equal to C plus D. Now by angle sum property, what we get? A plus B plus C plus D is equal to 360 degree. 360 degree. But by the theorem we have A plus B equal to C plus D. So instead of C plus D, we will replace A plus B. For this, we will replace A plus B. Thus, 2 times of A plus B, 360 degree. Therefore, A plus B is equal to 180 degree. So these two are sum up 180 degree. But both the angles are on the same side of a transversal AB of this two line segment AD and BC. Since the line segments AD and BC are cut by the transversal AB, and angle A and B are on the same side of the transversal. Therefore, the line AD must be parallel to BC. By the property of parallel lines, these two sum up 180 degree and these two lines cut by the transversal AB. Therefore, the line must be parallel. Similarly, we can prove that if AD parallel BC, then AB parallel CD. That is, ABCD is a parallelogram. Proved. Theorem 8.6. Prove that the diagonals over parallelogram bisect each other. So for that you need to make a parallelogram. A, B, C, D. As the diagonals, it's mentioned about the diagonals, you have to draw the diagonals. Now to be proved, the diagonals bisect each other, means these two parts are equal and these two parts are equal. Let it be O. Let the diagonals AC and BD of a parallelogram ABCD intersect each other at O. To prove that AO equals to CO and BO equals to DO. Any two pair of opposite triangles you have to take. Either you can take this two or this two. In triangle AOB, I am taking these two triangles AOB and triangle AOB, then COD, what we get? This angle is equal to this angle because of alternate angles, as AD parallel CD, so they become alternate angles. This angle is equal to this angle, they are also alternate angles. And moreover, this side is equal to this side. So always you have to mark the points like angles or sides. So AB is equal to CD angle ABO is equal to CDO alternate angles, and BAO is equal to DCO. They are also alternate angles, here opposite sides of parallelogram. Therefore, the triangle AOB is congruent to triangle COD by A as A. Now by using CPCT, AO, therefore AO is equal to CO and BO is equal to DO. CPCT proved. Next theorem, it just altered of that, means this time it is said you have to prove the diagonals bisect each other. Then it will be a in a parallelogram the diagonals bisect each other. But in the next one, if the diagonals of a parallelogram bisect each other, then you have to prove that it's a parallelogram. So what we do, what we have proved here, this will come in the proof part, and this 2 will come here. Okay. So here you write the statement. I have not changed something. Let the diagonals AC and BD of the parallelogram ABCD bisect. Here you have to write bisect. There it was written intersect. Bisect each other at point O. Therefore, we need to mention something like therefore AO is equal to BO. If you mention, you can mention or cannot also. AO equals to CO, BO equals to DO. To prove ABCD is a parallelogram. Prove. We have in triangle similarly you take this time we will take this side equal to this side, these two sides are equal, and it is a it's a pair of vertically opposite angles. In triangle AOB and COD, what we get? AO is equal to CO, BO is equal to DO. These are all given, and angle AOB is equal to angle COD, vertically opposite angles. Therefore, the triangle AOB is congruent to triangle COD. But here the proof is not finished. Why? We have to prove that it's a parallelogram. So for proving a parallelogram, we have to show the character of a parallelogram. That means either any two pair of opposite sides equal or opposite angles equal. So by CPCT, what we will get after making the triangles equal? This angle it is equal to this angle, and this angle is equal to this angle. So if one pair I take, this angle equal to this angle, they two are alternate angles. That means what? AB parallel CD. Similarly, by using these two triangles, we can prove that AD parallel BC. So here we will get AB, and therefore angle BAO is equal to DCO, angle DCO, but it is CPCT, but they are alternate angles. Therefore, AB parallel CD. Similarly, we can prove, like AB parallel CD, we can prove AD parallel BC. That is, ABCD is a parallelogram. Proved. Next theorem, you write the statement. If the a quadrilateral is a parallelogram if the pair of lines opposite sides are equal and parallel. So what is said? If one pair of opposite sides are equal and parallel, then you prove that it's a parallelogram. That means the other side you show equal and parallel. A, B, C, D. Let in the parallelogram, in the quadrilateral, A, B, C, D, AD parallel BC and AD equal to BC. To prove ABCD is a parallelogram. Prove here one thing you mentioned, let in the quadrilateral ABCD, BD is a diagonal, BD is the diagonal and this is BD is the diagonal and AD parallel BC. Here you write BD is the diagonal and AD parallel BC and AD parallel equal to BC. Proof part. In triangle ABD and ABD, then CDB. Triangle CDB. What we get? As these two sides are parallel and equal, so they are equal. Parallel, so these two angles are equal, alternate angles, and it's a common side. AD equal to BC, it's given. Angle ADB is equal to angle CBD, alternate angles, and BD is equal to DB, common side. Therefore, triangle ABD is congruent to triangle CDB by SAS. Therefore, AB is equal to CD, AB is equal to CD, and this angle is equal to this angle, angle ABD. ABD is equal to CDB. By CPCT, these two are CPCT. But these two angles are alternate angles, but they are alternate angles. Therefore, what happened? AB parallel CD. That means that is ABCD is a parallelogram. Proved. Now we'll be doing theorem 8.9, which is known as midpoint theorem. This 8.9 theorem and the next theorem 8.10 will be used in the next exercise, 8.2 exercise. So I'm teaching you all together. So what is the meaning of this theorem? If ABC is a triangle and if D and E are midpoints of the two sides, then what we get? The line joining the midpoints is always parallel to the third side, and another point is not mentioned here, that is half. Always it is the half of the third side. So for doing that, what we do? We draw one parallel line. Such a way we draw this line so that it will be parallel to DB and it will cut the line while producing this DE after producing, suppose it will cut at a point F. So that will come in a construction. Let D and E are be the midpoints of AB, of sides AB and AC of triangle ABC to prove DE parallel BC. Here in the theorem we can add up one more thing. The third side and is half the third side. And half the third side. So to prove this, and DE is equal to half of BC. So the construction part, CF drawn parallel to BD such that it cuts DE, not DE exactly, while produced. So here you have to mention produce DE at point F. Now we'll start the proof. In this triangle we will compare something. These two angles are vertically opposite angles. E is a midpoint, therefore AE is equal to CE, and moreover here these two sides were parallel, CF parallel to BD, therefore CF parallel to AD. That means these two angles are alternate angles. So these two are also equal. After making the triangles equal, we will make some of the sides equal to each other. In triangle AED and triangle CEF, what we get? AE is equal to CE, since E is the midpoint of AC. Angle AED is equal to CEF, vertically opposite angles. Last point, this angle DAE is equal to DAE is equal to FCE, alternate angles for alternate angles. Therefore triangle AED is congruent to triangle CEF by ASA. This side is equal to this side. AD is equal to CF, but AD is equal to BD. Therefore AD is equal to CF and AD equals to BD. That means these two sides are equal to each other. But AD is equal to dB. BD. Therefore, what we get? AD equal to CF and AD equal to BD. Therefore, these two sides are CF is equal to BD. These two are equal, and moreover these two were parallel, and BD parallel to and DE, it is CPCT, but and moreover BD parallel to CF. Therefore, therefore DBCF is a parallelogram. If it's a parallelogram, then DF parallel to, therefore DF parallel to BC. If DF parallel to BC, then DE is a part of DF, therefore DE is also parallel to BC. Therefore, DE is also parallel to BC. First part we have proved, to be proved that these two are parallel to each other. Now the second point that needs to be shown, that DE is half of BC. How is to be shown? DE is equal to CF. Again DE is equal to EF. That means, that is, DE is equal to half of DF, but DF is equal to BC. Instead of DF you write BC, since DF is equal to BC. Why? Opposite sides of parallelogram. Opposite sides of parallelogram. That means we have proved both of them. Therefore, finally what we get? Therefore, DE parallel BC and DE is equal to half of BC. Proved. This time the theorem is altered of that. What is said? In the earlier one we had proved that if both are midpoints, then this side is parallel to this and it is a half of this third side. Suppose A, B, C and this is DE, then DE parallel to BC and DE half of BC. These two had to be proved while giving that D and E are midpoints. But this time it's a different thing. It is said one is a midpoint, other is not midpoint. You have to prove that that is also a midpoint. So D is a midpoint. Here this point is given, D is a midpoint, and it's parallel to the third side. Then you prove that E is a midpoint. This point is not given. E is a midpoint and the sides are parallel to the third side. Then E is a midpoint of another side. Then E is a midpoint of the other side. Say here we will take E. Another more point we will take over here, F. This two to be joined, and here you join it by a dotted line. So let D be the midpoints midpoint of the side AB and E is any point on AC and DE parallel BC to prove E is also the midpoint of AC. Construction. Construction. Let F be the midpoint of AC. Now, if F is a midpoint, since F is a midpoint AC, therefore what we get? DF parallel BC. DF parallel BC. But we have, at the beginning we have DE parallel BC. Now, if one line is parallel to two different lines, that means what? These two lines must be parallel to each other. Therefore, we get DF parallel to DE. One more thing you have to add up with here, that of AC and DF is joined. So from above we have got these two lines are parallel, but this is not possible. But it's not possible. It is not possible. That means what? E and F cannot be two different points. That means two lines cannot be parallel to each other while drawing from the same point, which is not possible. That is, F cannot be the midpoint. Therefore, that is, E is the midpoint of AC. Proved. So I have completed all 10 theorems, and the last two theorems will be used in the exercise 8.2 and the previous theorems will be used in the exercise 8.1. So all those are very easy. Just you have to remember, go on using the properties of the triangles one by one, and parallelograms one by one. Then you will go on getting the theorems one by one. And in the next video, I'll be doing exercise 8.1 and some few more sums from 8 also. You can try at home if you can. So till then, be safe. Goodbye.